So the work I'm presenting today is based on a paper that was published on CPDP, which is the Conference on Computers, Privacy and Data Protection last year, and is joint work with my colleagues Carmela Troncoso and Seda Curses. So yeah, the outline, I will give a short introduction to the context of the problem, and very briefly talk about privacy by design in policy. I'm sure I'm not the one who knows most here about privacy by design in policy. Then go into what we argue should be like a cornerstone for a privacy by design engineering methodology, which is data minimization. I will go a little bit in detail into that. And then present 2 case studies of applications that, in our opinion, are good examples of how one can construct systems following a privacy by design sort of guideline, and conclude with some lessons learned. Okay, so implementing privacy in systems is very difficult. You cannot add privacy to a system like you add salt and pepper after it has been designed. You really have to take privacy requirements into account from the very beginning, and they are going to possibly have an impact on basically the whole architecture of the system that you're designing. So yeah, you need to take into account the privacy requirements from the start. Another problem is that we don't have very many good examples. We don't have many deployed systems that we can point to say this is what we consider a good system from a privacy by design point of view. Okay, so privacy by design, although design is a very technical engineering word, has been mostly coming from the policy world. So notably, Anne Katholieke in the IPC Ontario has been talking about privacy by design for many years. And this has also been picked up by like the European Commission and the FTC in different reports. So the question that we ask is, as an engineer, as somebody who designs systems, if you look at this privacy by design principles, what does it tell you when it comes to like sitting down and actually building a system? So just a quick summary of the privacy by design principles that Katholieke proposes. Proactive, not reactive, privacy as the default, privacy embedded into design, full functionality, positive sum and not zero sum. That means that you should not have to give up on functionalities that you would like to have in the system. End-to-end security, visibility and transparency, and respect for user privacy, which is user centricity. So what we argue is that the definitions of these principles are basically too vague to be useful for an engineer who wants to design a system. So just to give you an example, the third principle, which is privacy embedded into design, it says privacy by design is embedded into the design and architecture of IT systems and business practices. It is not bolted as an add-on after the fact. The result is that privacy becomes an essential component of the core functionality being delivered. Privacy is integral to the system without diminishing functionality. So this is a bit of a recursive definition. So privacy by design is about applying the privacy in the design, but basically if you want to design a system, it doesn't really give you much information about how you should go about it. So as I said, we argue that aggressive data minimization is a good approach, is an important a principle that one should take into account, but I will come back to this in a few slides. So first of all, this data minimization concept, is it reflected in current policy documents? Yes and no. So if we focus on the Data Protection Directive, it states that the data must be collected for specified, explicit and legitimate purposes. So this is like the finality, the purpose specification, and it must be adequate, relevant and not excessive in relationship to the purpose. So some scholars actually argue that from these principles one can derive that you should really minimize the data that you collect and process to that that's strictly necessary for the purpose and so on. But this is sort of derived or inferred from these 2 principles, but there is no explicit mention that you should use as little data as possible. And if you have 2 alternatives and one is using less data than the other, the one that's using more data is not good, is not compliant with data protection. It doesn't go as far as to say that, right? So the problem with the way it is articulated in the Data Protection Directive is that it is very easy to subvert this proportionality clause by, for example, defining the purpose to include as all the data that you want to get, right? And then you would be able to get it. And then data protection also puts a lot of emphasis on providing users with control on their own data and with transparency. And this is usually in the form of informed consent, in the sense that in order to collect and process data from people, you need to get their consent, and they need to provide it to you. And then they have certain rights with respect to the data that you collect from them. They have the right to access it, delete it, correct it, and so on. So the problem with this is that what does mean informed consent when you often don't have any choice, in a way that, for example, if I wanted to have a mobile phone service that I can use without being tracked without the possibility that my provider is tracking me, I don't really have any available choices. So I have to consent to my data being collected and the tracking being possible in order to use a mobile phone. So is this really informed consent? I mean, I have no option to consent. So I don't think one can really, it's not that you're given a choice, basically. And this is in mandatory systems. I mean, there is not even the option of consenting, like if you want to have electricity at home, which is a reasonable thing to have, and you have a smart metering. If the smart metering is not doesn't have really strong privacy protections, you basically are going to be revealing the data, and there's nothing you can do about it. And then another problem with subject access rights is that they apply to what is called personal data, which is not all the data they have about you, right? So this is typically restricted by doing some simple anonymization. They can take a lot of the data that is related to you out of the scope of the data protection directive, saying, no, well, this is anonymized data, therefore all these clauses and rights don't apply anymore to it. And you only have access rights and so on to this little part that is maybe your name, your credit card number, date of birth, and so on, but maybe not your behavioral profile, because that has been aggregated with other people's and is not considered to be personal data anymore. So it slips out of your control, essentially. So from an engineering perspective, we have the impression that there is a disconnect between the policymakers and the engineers and what it means to build technologies that address, that solve, that mitigate privacy concerns. And the problem with the conception of privacy by design that we find in policy documents is that to some extent one can interpret it as collect and process as much data as you want, but with a privacy label, meaning that you have to make you have to have some policies, and you have to get the consent of the users, and you have to define your purpose. So you have a little bit more overhead, but that doesn't mean you're going to collect less. And from a security perspective, having this control and these transparency mechanisms is not going to mitigate all the security risks that arise from having large databases in which large amounts of data are aggregated, in the sense that this becomes a single point of failure. This is an attractive target for all kinds of attackers, both external attackers where hackers who might want to break into the system, but also people who are authorized to use the database and might want to use it for a secondary purpose, malicious insiders, and so on. It is also important to distinguish between two different types of risks. I have the impression that when people talk about privacy, often they are referring mostly to the risk of public disclosure. So your privacy is violated when your information becomes sort of publicly available in the internet. But there is also the risk that even if this never happens, so when people talk about Facebook and so on, it's typically these examples that are given, like your employer got to access your information or it became publicly available. But there is also these other risks, which is that the entity that is authorized to collect the authorized to access the data might also abuse it in a very stealthy way that is not at all visible. Such as, for example, making profiles of you that then have an influence on whether you get access to a service or not, and so on. So often when, especially I think in the policy world, when people are building technical systems, they tend to somehow mimic how things work in the physical world. So they try to reproduce the processes and map them to the digital world. Now the problem is that there is some fundamental differences between physical and digital world that we think cannot absolutely not be ignored. So for example, in the physical world, it's difficult to replicate information. In the digital world, it's very easy to replicate, disseminate, and so on. If you have paper-based information, it's very hard as well to do statistical inference because you would need to have the computing capability to be able to do that. Linking is also difficult if you have different separate archives where the information is sitting. So this becomes very easy in the digital world. On the other hand, we can also do things in the digital world that are not possible in the physical world, thanks to the computational capabilities of the machines that we have, in the sense that we are able to do the same, to achieve the same functionality while using less data. And I think this is definitely not well understood in the beyond a small community of security researchers, in part because we don't have really good metaphors to explain what these technologies can do, so people sort of don't understand them and then don't pay too much attention to them. So the effect of using these sort of advanced technologies that really take advantage of computational capabilities is that we can take data minimization much further than what one intuitively would think about data minimization, which would be that you restrict sort of the attributes that you collect. We can go a lot further than that, and this is not so easy. I will try to illustrate this with the two examples that I will present, the two systems that I will present. So this is actually not in the paper that is available. This is because we are still sort of working on this topic. And the thing is that data minimization is also not a very good phrase to express what these technologies do with respect to how they treat data. In the sense that it's not necessarily that there is less data in the system. That is not the only thing. It could be, well, of course, minimizing the disclosure, but it also refers to minimizing trust, the need to trust other entities. Trust is also a word that has become very fashionable these days, and everybody's talking about trust. The problem with trust is that when you have a trusted entity in the system, you're basically relying on that entity to provide you with the security properties that you seek. That doesn't mean that the entity is going to act in the way that you are expecting. It means that if it doesn't, your security is gone. So it's not necessarily it's not a good thing to actually relying on others to protect your privacy. You should minimize that to the extent that is possible. It is about where the data is residing. So sometimes if you take the system as a whole, meaning the backend, the user devices, everything together, the data that you have is the same in both types of systems, like privacy by design and non-privacy by design. Now, it might be that in the privacy by design system, the data is not collected in a central store, but rather each user is somehow keeping his own data in devices under their own control, so in distributed architectures. So it's also about minimization of risk. So how do you make data breaches less likely? And so, for example, by reducing incentives to break into the system. And also, if a data breach does happen, how do you diminish the impact that it would have by having, for example, less data that would be lead to a less serious privacy breach? And then other issues such as the number of places where you replicate data or the amount of time that you are keeping it around. So basically the two main points here is when we talk about data minimization, it is not just what we would intuitively understand. That is one, and the interpretation of data minimization has to be understood in the context of the state-of-the-art privacy technologies. So we can distinguish actually two main families of technologies for achieving data minimization. One is anonymity. Anonymity is, I think, the best understood of the two. Basically here the idea is that the service provider would be able to see the transaction details, but would not be able to see the identity of the person conducting the transaction. Of course, it is very difficult to have robust anonymity. You need to have it on many layers, not just on the application layer, but also on the network layer. If it is enough for one component to fail to provide anonymity for the whole thing to collapse. And I also have the impression that in the policy world it's completely not understood what anonymity means, in the sense that many people seem to think that you remove the name and some obvious identifiers and that's it. and this is completely not the case. And if we go to more technical definitions such as anonymity sets and so on, it gets much more complicated and not so intuitive. So the other family of technologies is, we don't really have a good name for them, but they include things like private information retrieval, oblivious transfer protocols, and so on. And here, the identity of the user is known to the provider, and what we do is conceal the transaction details. Okay? So basically, you have identity, transaction details. You can achieve privacy by concealing identity. You can achieve privacy by concealing transaction details. You can also combine both if in some systems that could be very interesting as well. And yeah, again, the intuition of this is not easy. So I will illustrate this with two case studies. The first one is relying on anonymity. It's an e-petition. This is a separate work that we did some years ago. So as you know, I mean, petitions are basically a request that is addressed to an authority, signed by many people. And in the physical world, when you want to get people to sign a petition, people typically have to provide a unique identifier, like ID number and a signature. And then to validate the signatures, they are going to check whether the ID numbers correspond to real people, match the name and so on, and the signatures are also matching. And if somebody has signed several times, they will discard the multiple signatures. So of course this is super costly, like you have to really deploy people on the streets, go and collect signatures, you only reach a small part of the population and so on. Similarly, verifying is very tedious, so by going electronic and automating everything, everybody can sign from their home and so on. This is, it makes much easier, lowers the barrier of participation. And there are some initiatives at the European level for having a system, European Citizens Initiative, in which if 1 million signatures is collected, then Parliament, I think, would be required to consider the subject of the petition. So, as I said, I mean, there is a tendency to mimic how you do things in the physical world and reproduce it in the digital world. So, I'm now going to describe how one would do this in this application case. So, there is no EID here, but in Belgium we have electronic IDs. So, and they have signing capabilities, so you can just have people sign with their EID. How this would work is that you go to some website, you have your ID and some card reader that you can use. You use two-factor authentication, PIN plus possession of the card. You select some petition, sign it, and that's it. And then the signature is counted or discarded if you sign several times. Now, the problem here is that, of course, this reveals all the information to the person or to the institution collecting the signatures. As I mentioned, here we have two types of risks. It could be that if the signatures end up being made public, some people might actually not want to sign because of potential negative consequences. So imagine you are living in a certain community with certain values, and maybe you are not actually agreeing with these values, and you would like to sign a petition that would not be popular within your community. If it is known that you are doing this, then you would maybe, might have problems with your neighbors, your family, whatever. So if you know that this could become public, you might not sign. And on the other hand, you could also have abuse in the sense that you get profiled because, I don't know, you are in favor of building mosques in the city, and then the law enforcement considers that people who think that should be, closely watched because they have a high risk of being terrorists or whatever. So the thing is that with petitions, typically they are on controversial issues. So they leak actually sensitive information about political inclination, political ideas, religious beliefs, and so on. If you're signing them with your EID, that means that there is a public key that is associated with your signature that is associated also with any other transaction in which you have used your ID. So it becomes linkable. It is very easy to aggregate it to all the other activities. And of course, this is not comparable to the risk that you would have in a paper-based petition, in the sense that in a paper-based petition, this is in some physical drawer, and there is a cost of accessing the information and linking it that doesn't exist in the physical world. So that barrier has dropped, and therefore we cannot compare the risks that we would have in the two alternatives, right? So the thing is, can we do this, if we wanted to do this in a privacy by design manner, how would we go about it? I mean, this is already a paper that existed prior to this work, so we took it as an example because we thought it was a good example. So basically, the first step is to define the functionality. So what does this system need to do? Absolutely. So you need to know that that the signature belongs to somebody that exists, so a real person. Is not like I cannot sign for somebody else, or I cannot invent a new citizen. You might have some attribute verification, so maybe only people who are of age can sign, or maybe people who are residents in a certain city can sign, if it's for a local petition for, I don't know, the town school or whatever. And you need a uniqueness, of course, because the point here is to know how many people signed support something. So if I can sign for 1 million people, then 1 million signatures don't mean anything at all. And yeah, correctness, you want all signatures to be counted. So, of course, in the physical world, we cannot, we need to identify people to be able to fulfill these basic requirements, right? Because otherwise, how are you going to check that somebody is not signing several times and so on? Unless you go into something like an election, in which you have like several stages, people registering in one place and voting another, but this is like super costly, and it's not realistic to expect to do something like this for each petition. So from a privacy perspective, we can say, okay, we would like that I would like to be able to sign petitions without anybody being able to see that I have done so. And in fact, this is reasonable because the point of a petition is to see how many people support something. You don't necessarily need to know who they are specifically, right? It doesn't make a difference. Of course, one can say, yeah, but you know, it's important sometimes to make a public statement that you want to support something, but this is not stopping anyone from doing so. You can still go to your website or to TV and say, I signed this, I support it. This is not going to be prevented by the system, but the thing is that the system shouldn't by default reveal this information. So the basic building block that is used here is anonymous credentials. I'm not sure if you're familiar with anonymous credentials. I'll try to give a very high-level introduction to them. It's a sort of PKI, and it has many similarities. So there is some trusted issuer, typically what is called like identity provider. Typically, in the case, if we're thinking of like EIDs, it would be the state that gives you an ID that certifies that this is your name and this is your date of birth and this is your town of residence or whatever. And then you're going to have some secret key that you use to prove that this is your credential. So this is the same in both PKI and anonymous credentials. Now, the difference is in that in PKI, you have like this certificate that every time that you want to sign something, you're going to have to show, you will show all the information that is in the certificate. And then also because you have this public key that is visible to anyone who wants to validate your signature, all your signatures are going to be, it becomes like a pseudonym. This public key becomes, because even if your name is not encoded, the public is a pseudonym, so all the things that you sign can be linked together. Of course, if you can link all my transactions together, then you don't have anonymity anymore, because at some point you have so much information about me that you can re-identify, right? In the case of anonymous credentials, you are able to select which attributes you're going to show, and not even all attributes, full attributes, but sometimes properties of attributes. So for example, my zip code is such that it falls within the town of Oxford. And maybe there's, I don't know, 20 zip codes here, and you will not be able to see which one it is exactly. And it's also, if I use the same credential to interact with different entities, they will not be able to find out that they were interacting with the same person. So just to make it a little bit more clear, so basically we have some issuer, the approver is like the user who is going to have the credential, and the verifier is the person. In this case, this is the petition server, right? So this is the state, this is the person, and this is the petition server. And the idea is that the user gets a credential from the issuer, and then is going to be able to use it to sign or prove attributes to the verifier. And when these two, the issuer and the verifier, get together and they try to find out, okay, so I issued a credential to this bunch of people, and then he's going to say, oh, I saw this signature, and they try to combine the information that they have to see which is the person that signed, they will not be able to find out who it is. That's the idea. So this is a prototype implemented. So yeah, this part is basically that once you have the credential, you sign the petition, the protocol runs, and you can detect multiple signing. If there is no multiple signing, the signature is counted and published. Of course, how do you get the credential? That's a bit the bottleneck. So in an ideal world, your electronic ID would actually have this protocol inside. Of course, this is not the case. So what we did was that we used the current existing Belgian EID to go and be able to get a credential from some other server. And once you get that, you don't use the EID anymore, and you just use the anonymous credential. So what used like a root of trust, basically. So in this system, we actually fulfill the properties in the sense that only citizens that are entitled to sign can do so. They need to prove that they have the ID and the PIN, and the attributes can be verified in the sense that even if you're not showing your age, you can prove that your age is over 18, if that's a requirement, or under 14 if you are accessing something that is only for children or whatever. And there is only one credential per citizen. Citizens can only sign once because the protocol basically detects when a multiple signature has been created. The way this is done is that there is a random number, a pseudo-random number that is generated from the signature and the identifier of the petition. When the same person signs the same petition twice, this number is going to be the same, meaning that you're going to see, okay, these two signatures are actually the same. Now, this allows for deleting duplicates. I want to point out that this does not allow for de-anonymization of the person who has signed more than once. Often when we talk about anonymity, people raise concerns of, but what happens with accountability? What happens with people who try to abuse the system and so on? In many cases, we can actually prevent abuse without the need for re-identification, and this is actually one of them. And then the tricky part is that the protocol is very nice and it doesn't reveal your identity, but if you're not using an anonymous communication channel to run the protocol, then you can be identifiable through your IP address or through your communication, at the communication layer, basically. So this is a little bit the problem of anonymity, that you have to take care that is not only achieved in the application protocol, but also that you're anonymizing your communications, because otherwise, even if I cannot identify you through the credential, I can identify you through your network trace. So this was the first example. The second example is electronic toll pricing. This was also work that was done by some colleagues. So in KU Leuven. So I guess you're familiar with toll pricing. This is basically the idea that instead of paying a flat tax for the car for your car for using roads, you would pay depending on how much you drive, right? And there is a European decision mandating that this should be implemented and rolled out in the next few years in Europe. So again, the straightforward implementation, which is the one that companies came up. This was actually done in the context of a project with industry. So this was like the architecture that they were proposing in the beginning, is that you have, so the OBU is onboard unit, and it's a sort of black box that you have in your car. So this is going to be to receive like GPS coordinates to know where it is, and then it's just going to relay them through the GSM network to the provider, who is going to collect all of these GPS points, map them do the matching to a map, see in which roads you are, compute the price, and then just send you a bill, and then you pay. Okay. So the problem here is that this is as you're driving, so it's very fine-grained location information, and this allows for all kinds of inferences. I mean, your location traces are extremely rich in order to draw inferences of your lifestyle, your people you hang out with, and your religion. Like, do you go to church on Sunday? You don't drive on Saturday? Or I mean, there is all kinds of inferences that can be drawn from it. So again, we ask the same question as in the previous case, which is, what is the functionality of the system? What are we trying to achieve before we go into having an architecture? So in this case, what we're trying to achieve is that the user pays for the usage of roads to the government, and this fee must be the correct amount. This is what you are trying to do. Yeah, this is what the system is for. The system is not for collecting everybody's location data. And if we want to build a system for collecting everybody's location data, then we should talk about that. And we should say, okay, let's build a system to collect everybody's data because we think this is a good idea. But sometimes what we see is that they say, oh, it would be great to have pay-as-you-drive because it's good for the environment. People would drive less. It would be more fair economically because now, people who are not using the car are paying the same as those who are using it a lot. And we build it with the architecture that I just explained. And, as a side benefit, we get all this location data that then we can use for law enforcement and all other kinds of services or whatever. So basically, what we try to point out is that in privacy by design, it's very important to have a very specific functionality, because with a specific functionality, we have very nice privacy technologies that can actually provide that functionality. The problem of leaving like open-ended functionalities is that then you can subvert them, and then there is not much you can say about the privacy guarantees of the system. So basically, if you have a system in which only the final fee is the information that is revealed, then we are reducing enormously the risk of a privacy breach because, okay, yeah, it's sensitive information, how much people are paying, but it's not as sensitive as what is their full location trace for the year of the month or whatever. So this central database becomes much less critical. Well, of course, we want also to make sure that the integrity of the system is guaranteed, so that people are not able to cheat, and if somebody is cheating in the system, it should be possible to pinpoint what is going on and who is cheating and so on. So the alternative architecture that was proposed by our colleagues was as follows. Again, we have a black box in the car, OBU, onboard unit, that is going to receive the GPS information from a satellite, but instead of just relaying it to the provider, is going to do the computations locally, okay? And then is going to compute the final fee and say to the provider, this is how much I have to pay, okay? Then the user gets the bill, and then the user is able, with some crypto, some USB stick that contains some crypto material, to access his own trace, to check that, okay, I have to pay 100 euros this month. This sounds like a lot. Let's see what, whether there is something wrong. There is some, he wants to contest maybe the bill. Now, the problem with this is that in terms of privacy, the adversary in this system is actually the provider. Right? So the provider is assumed to be adversarial in the sense that wants to find out as much about the users as possible. If we think about integrity of the system, service integrity, then the user is the adversary in the sense that the user has lots of incentives to cheat, to pay less. And the problem is that you are giving him a device that is under his full control. So this is a little bit like the TV boxes that people hack in order to be able to watch TV for free. In some cases, you can say, okay, well, we make a box that is tamper resistant and we'll solve it, but this is not possible here. Why? Because even if the box is tamper resistant, you can just feed you don't open the box, but you just feed false GPS data to it. And then it would believe that it's in a different place. Or you just don't take it with you. It's very simple. That's the easiest one, actually. So the protocol or the system needs to detect like when vehicles are not having active OBUs, or they are cheating, they are reporting false data, or cheating with the prices of the roads and so on. So how does it work? A bit of technical details now. So we have basically, on this side, we have the box that is sitting in the car of the user. On this side, we have the service provider. Each of them has some crypto keys. So the provider is going to, this is the policy. So the policy describes the type of roads and the price that is associated with the type of road. So the example policy that they chose was that you have like highway, primary road, and so on. the time of the day, and then a price associated with it. And this is signed by the provider. So basically what the OBU is going to do is receives the GPS points, has a map inside, is going to do the matching to the map. Look for the price. You say, okay, so I'm in a highway, and it's 6 in the morning, so I have to pay P1 per kilometer. This information is encrypted, which is equivalent to putting in a safe that cannot be opened by anybody who doesn't have the right cryptographic material, and sent to the service provider. So when it is sent to the service provider, the user cannot change it anymore. Okay, he has committed to whatever he put in here. And then it is possible later in time for the box to actually provide the clear text data, some cryptographic material, and show that this material, so the map and the price, is actually what was encoded in here. So prove what was inside. So this is the basic primitive. This primitive also has another property, which is that it's homomorphic. What this means is that when you take the price part of each of the commitments, so each commitment is for a kilometer. Okay, so you divide your trajectory in kilometers, you pay per kilometer, and you have put each of these in a safe. Right? So the thing is that you can actually operate on these safes and sum the part of the prices in the encrypted domain without needing to decrypt it. And then it is possible for the user to provide the cryptographic material to say, when he says, I have to pay 50 euros this month, to provide the cryptographic material that says, and the boxes that you have received, when you use this cryptographic material, you see that they actually sum up to 50 euros as well. Okay? So this is not, we also need some additional checks, because we also have the problem that you might not take the box with you. So if the box is not really built into the car, it is very easy to cheat by just not switching it on or whatever. So the mechanism for detecting cheating is based on random spot checks. So this is like when you go in the metro, and once in a while you get somebody saying, may I see your ticket, please? And if you don't have it, you pay a big fine, so you don't really have incentives to not buy the ticket, because you can just put the frequency of checks and the price of the fine to make it non-economic. So here the idea is that in the normal operation, the OBU, the box in the car, is sending these commitments, or sends them once a month. At the end of the month, sends all the commitments to the service provider. And at some point, this car might have been spotted somewhere. Okay, so the idea is that you can the service providers, the toll charger, toll service provider, they can actually challenge the box to prove that the place where it was spotted was included in the reports and was paid for correctly. Okay? So the OBU will be challenged to provide the right cryptographic material, and they actually can do the check. If you haven't reported that location, you will not be able to prove that you paid for it. If you didn't include the right price, you will not be able to prove that that you did so, and so on. So basically, with the random spot checks, one can detect abuse that is even like switching off the box. Okay, so what are the lessons learned? I mean, this is very preliminary work in the sense that in order to really extract the methodology, we would need to have many use cases. So this was like a starting point. Let's take two cases that are actually different, based on different techniques. So one on anonymity, one on hiding the transactions, but without the identifiability. So in the case of road tolling, they know who you are. I mean, you have a license, your license is registered, you have a record. I mean, it's not that you can be an anonymous driver, right? So, but we can already extract some sort of high-level steps that should be taken if we are talking about a privacy by design methodology. So first and most important is the definition of the functionality. And this is a big problem because often the providers, they want to leave functionality open-ended, right? So they want to be able to extend it or do additional things. And of course, if you want to have an open-ended functionality, then you cannot really provide privacy warranties, because if you can always change the functionality to be completely privacy invasive. So if the system is flexible, this is not going to be possible. But if we have a specific functionality, then we can start talking about how to ensure that the system will only be will only be used for achieving that and not nothing else. Okay. So then, if we talk about so how can we now minimize to achieve this functionality? How can we do this data minimization? And as I said, this is it's not an intuitive concept, because it's not just about minimizing data. So we have all these dimensions of temporality, centralization, trust, and so on. So the idea is that you should find the minimum, first find what is the output of the function that you want to compute, and then see of all the inputs, how can you minimize the disclosure of inputs that are necessary for computing this output, taking into account that it's not the same having my information in my local device than having it in a central database. Yeah. Then you have to basically look into state-of-the-art technologies and see what protocols are out there that you could use, or design your own protocol if none of them is suitable for your application. And then you have to do the whole threat modeling. So what is your attacker? What is your risk? How do you do what is your security analysis? What are your guarantees to actually provide privacy properties? And of course, take into account not only the privacy requirements of the user, but you might have like integrity requirements for the service provider, so that cheating detection or prevention, for example. And then this is not just something that you do linearly. You usually have to go back, because in the process you probably have modified, when you did the multilateral security analysis, maybe you had to modify your initial assessment of how you were going to do things, and so on. Then there are other considerations that are beyond actually the engineering expertise. So one is the legitimacy of the functionality. As engineers, this is not our job to basically decide whether a functionality is legitimate or not. This is something that is somehow out of the system. So it has to be, but it has to be taken into account whether a functionality to start with is legitimate. There is also the issue of surveillance. So I'm hearing, especially lately, quite a lot about doing privacy by design for surveillance systems. This is, to me, is a bit cognitive dissonance in a way. And I think our position on this is that if the purpose of a system is to do surveillance, then this is somehow incompatible with privacy by design. I mean, in a sense, we think that it's misleading to say that you're going to design a surveillance system with privacy embedded in it. And this sounds like really washing surveillance systems in a way. And then there's risks that are non-technical, such as discrimination and so on. So just coming to the conclusions, I mean, we argue that basically data minimization, whatever we define it with, still is not very well defined, must be an important cornerstone of privacy by design. So it's not just about, we design this system and then we give all this data to an organization and then they have some business practices that basically are going to ensure that everything is fine, and then we have privacy by design. I mean, we think this is not really taking into account basically the whole state-of-the-art research in privacy technologies. And then why are we talking about design if it's going to be reduced to business practices? It's not only about anonymity. We have other options. Sometimes you can be identified and have very strong privacy warranties. And I think we need engineers need to develop better intuitions and better ways of conveying what state-of-the-art technologies can do. I don't think we have good metaphors to convey that. One of the problems is that these technologies are not really accessible to the general public or even to people who are actually developing systems for companies, working applications. So the expertise that is needed is very specific and very few people have it. And we need more examples of deployed systems that we can point to as examples. One promising one, I think the road tolling example is very promising. A very similar concept has been proposed for smart metering, in which your smart meter, of course, you are identifiable completely, and they will be able to charge you according to to the energy that you have consumed, but they will not get the fine-grained energy consumption data. It's very similar concept, actually. And with respect to methodology, this is a very, very preliminary step, and the purpose of this paper was more to somehow counter all these arguments we were hearing that privacy by design was about, good business practices without really taking into account technology. So was trying to push back on that by saying, no, technology must have a central role here. And the problem, another thing is the checklists. So, of course, the organizations that need to comply with privacy by design, that would like to develop products with privacy by design, they would love to have a checklist that they just tick, 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 and then it's privacy by design. But we think that this is not really possible in the sense that, especially looking at the examples of checklists that are out there, they can be very easily ticked away for compliance without really meaning anything in terms of the design of the system. And that's it. If you want more information, the paper is available online. Thank you very much. Did I go over time?
So, do we have any questions? Hi. Have you given much thought about the externalities of this kind of approach, or the economic aspects of proposing something like these particular methodologies? The specific reason why I mention this is when you mention your toll charging approach. Storing the charging information in all these different nodes, it introduces a concurrent update problem, where you want to change the pricing. You now have to update all the nodes, as opposed to just the central model. And you have an uncertainty now introduced into your system as a consequence of your distributed storage mechanism. Now, that to me is introducing consequences that may be undesirable. And have you got much of a handle as to how you deal with those?
So, if you have a centralized system, but you still have these OBUs going around, you're probably going to have to push software updates. So does it really increase a lot to do policy updates? These policies are not very big. They're basically a table.
Payment. If it means that I suddenly can, if by changing the update schema, I can keep the old pricing strategies, legitimately, keep the old toll charges by shielding my device. It's still there, but it's running old pricing. Or if it means that someone can, you've updated my pricing strategy and it's not as cheap as it should be. It makes a difference to my pocket, which matters to me more than this concept of how private I am.
Yeah, I mean, obviously, if you want to change the policy, you cannot do it just like this. You probably need like a month in which you are start distributing the new policies, and then wait to activate it when you're sure that you have reached very significant, if not 100% of the population of the vehicles. Indeed, it complicates things in that sense. On the other hand, the costs of maintaining these centralized databases, the costs of having a privacy breach on these centralized databases, the increased probability of having a data breach because the data is very attractive, these costs are reduced. So, of course, we are not economists. We haven't done an economic analysis on what would be the impact of all these different choices, but it is not immediately obvious that this privacy the privacy enhanced solution would be necessarily more expensive. Yeah.
I think that the big point to me is that the costs are borne by different people.
Yeah.
And so the economic incentive to adopt this model is now placed on the operator, as in the increased cost of operating this is on the operator. The economic story for doing so isn't actually clear. And so maybe it's tied into a legislation.
Yeah, sure. I mean, this will not happen unless legislators push for it. This is very clear. And actually, the ones with more interest in this kind of architectures are companies that have been bitten by regulation, like in the Netherlands, for example, with the smart meters. They developed a number of smart meters, and then the commissioner said this is not good enough because it's privacy invasive and so on. And now it seems that they are super keen on having zero knowledge in their meters, right? And with this case, I think it was also in the Netherlands. They also was they said that they could not just deploy thin clients. So the thin clients are the ones that are just relaying the information and doing nothing else. That people should be given the choice of whether they want to. I mean, and sometimes you have to. Maybe you have to pay more if you want to have the privacy enhanced version. But at least you should have the choice, right? So it is clear that companies on their own will not do it, especially because this is not like a market with thousands of players. This is a market with very few players. They can just agree on, and they also take benefit in having all this data for analysis, for other purposes, whatever they are. So yeah, regulation is super important. But I mean, also this privacy by design concept is being pushed by regulators in a way. So, yeah.
Continue on that is why do we need GPS data? Because you can also have sensors in the road. It's only given location, and because you said maybe this GPS data can be used for the user to prove that he was somewhere. So we actually try to split these systems into different systems so that they don't spill over information. So try to prevent spillover by reducing also lots of updates problems and other problems to separate these issues.
Yep. So the architecture is given. That was the European decision, the Commission. The architecture was fixed.
And you could not fight that.
Yeah, it was not that you could say, well, instead of having an OBU in the car that does this and that, we'll have sensors and maybe you make micropayments every time you pass by one or another.
Privacy by design, you would not consider that by fighting against such architecture.
Yeah, well, yeah, no, in this case.
The first step. You first have to design of the system. If the design is given, then you actually adapt the system towards privacy, and maybe you have to do it the other way around as well.
Yeah. Yeah, sure. In this case, it was constrained in that respect because, I mean, there was no option to say, okay, let's do it completely different. So the regulatory framework had put some boundaries on that. Yeah. Thanks.
So I've got a slightly controversial question, and it sounds like that a methodology for engineering privacy by design might actually get in the way of doing privacy by design. Because I was working through your case study examples, and it appears that the approaches you selected have inherited a lot from secure software engineering and secure requirements engineering. So data minimization sounds a lot like minimizing attack surfaces.
Absolutely.
Well, threats and risks and whatever, and it's good. I mean, there's a lot of useful stuff. But see, the thing is, in security design, we've always had this assumption that security is an instrumental value, because usually we're applying these in organizational contexts where people adhere to very specific organizational norms, because if they don't work for the organization. So going through your examples, especially the sort of tolling example, so you dealt with the risk and you put a particular control in which dealt with somebody cheating, but it still minimized the data. But thinking of that in the real world, someone might say, hold on, you've just put a camera in the context, and it might not actually matter that the data's collecting isn't traced back. Someone might say, hold on, you've put a camera in there, and they're not going to care what it's actually collecting. It's actually changed the actual the social norms. If it changes the social norms in contextual integrity money, it's actually privacy invasive. And we could go into that example in more detail because engineering, it's a difficult thing, and we mitigate this by doing that, and mitigate that by doing something else. And the danger that I see is that somewhere along the line, although we are concerned about anonymity and pseudonymity and unlinkability, somewhere along the line, these become values, just like confidentiality and integrity. And as soon as these become values, they become instrumental values, and they're just trade-off concerns. And people might say, well, privacy is actually intrinsic. So to deal with it, you have to basically step out of the engineering methodology and go back to all the CSCW, all the value-centered design work.
Yeah.
So this tells me that perhaps engineering privacy by design isn't a good thing. Maybe what we want to do is just do classic CSCW and then security requirements engineering.
Yeah, I mean, this is, I mean, actually, one of the colleagues who worked in the paper said that she's totally coming from security requirements engineering. So this is inheriting massively from that. With respect to the cameras, I'm not sure I understand your concern in the sense that it's not that cameras were introduced in these architectures, that cameras were out there already. And it was a way to actually, instead of revealing full traces, revealing specific points once in a while.
Yeah, okay, so perhaps if
I'm not sure.
was already in the context, but the notion of mitigating one control with another control,
yeah.
I mean, inevitably there'll be further mitigations, and unless you have a superhuman team of engineers, at some point people are going to start treating anonymity and unlinkability as values, just like integrity and accountability. And as soon as they treat these as values, that can contend with other values, and that we might sacrifice one for the other, because you know we're trying to engineer a system, right? As soon as they do that, people might argue that, well, that's not privacy by design anymore.
Yeah.
Because it's just another value. It's just another security value. But privacy, people might argue, isn't. It's intrinsic.
Yeah. I mean, absolutely. I mean, basically, I think part of the motivation to write this paper was to bring security engineering a little bit more into the picture because we hear all this privacy by design talk from policymakers that is quite uninformed, I think, with respect to security engineering. And one cannot ignore that if you are proposing that systems are designed in a privacy by design manner, this cannot sort of ignore security engineering. But this is a lot of what they do, in the sense that they just talk about, you know, organizational measures and good practices and I don't know what, but not about actually reducing the risks from the beginning and doing it seriously. So it was a little bit, the idea of this paper was to put this into the picture and to try to push back on all this business approach that would basically legitimize mass collection. And then say, oh yeah, but it's okay because, you know, we are data protection compliant and we have some good practices, and therefore give us a label that we are privacy by design.
So this is really engineering security and privacy by design.
Yes, but I mean, from our perspective, privacy is security. Okay. To me, privacy is security. To me, privacy is security. So whenever I hear people, and sometimes I still do, saying that you have to trade off security and privacy, this is very weird to me. To me, yeah. So yeah, it's security. I mean, even you can just formalize it as confidentiality, right? Like having anonymity.
Yeah.
Having anonymity, you can see it as having confidentiality of identities instead of confidentiality of content.
Yeah.
Right?
I don't know. You might want to read some of the CSCW literature on sort of privacy, because they would argue there's a lot more to privacy than just saying it's just.
Well, of course, there's a lot more to privacy if you take. I mean, privacy can mean many things. It's also a psychological state of mind. I mean, it goes far beyond computer science, right? But if we are thinking about systems that sort of minimize privacy risks, and in my thinking of privacy, this comes down to minimizing the need to trust other entities for achieving your security/privacy properties, minimizing the risks of exposure, making sure you're not vulnerable to attacks, defining what is specifically how you formalize privacy in a system. What are you trying to achieve? My privacy, you have to say, this system protects privacy if my location traces are not becoming known, if my identity cannot be linked to my petition signature. I mean, you have to formalize it in some way and prove with some security analysis that this is really achieved. So yes, to me, privacy and security, I mean, of course there's nuances between the two, but it's part of the same thing. From my perspective, I understand privacy is much broader than that.
To be a bit, to try to be constructive on number plates. In the Netherlands, there's a study about, cars, truckers being robbed by Albanians or other people. So they go on a car parking lot and they want to find out how often the number plate goes over the car parking lot. So there are lots of discussions about where should the data be encrypted. Should it be encrypted in the in the pole itself before it is sending the data? So before the data is coming to the server, what should we do in advance in trying to minimize exposure? Because in the end you want to find out how many cars go from car park to measure it. But in the same time you have police cars who are checking those car parks. So there are some known entities and some unknown entities. And this can maybe help you construct to prevent that if you take these license plates, that you also make sure that this additional stream gets more anonymized in that way. Actually,
I think I've seen papers trying to solve that. You have
discussion about this. About what do we want? Do we try to prevent attacks, or do we try to be anonymous? This is balance between both sides, and the same problem is with security and privacy, that you have to find this kind of a balance.
I think I'm not. Yeah, I think I read something that they were trying to say, okay, to set some thresholds, so that
thresholds and trying to test it, to see if they still can identify police cars in that way, and being anonymous. So.
But I don't understand why they don't just have like some police dressed as like non-police, like going around to the car parks and doing police work. What is wrong with that?
It's all minimizing cost in the end. So if you look at Belgium, the deficit, and the Netherlands deficit, there's of course a difference.
But you think that this...
But also you should try and keep it close to the user as opposed to outside of their control. I wondered if you thought at all about how those two might interact. So for example, if I had, say, a mobile phone and a laptop and a tablet, and I was storing data on all of them, is my privacy by design better there than if I stored it in one place centrally? I mean, these things don't seem to be independent.
That's a good point. I think you have to go into risk analysis there. So what is the risk that any of your devices will get compromised versus what is the risk that the database that keeps everybody's information will be compromised? What are the incentives for compromising one or the other? Of course, you have the problem of end user devices not being completely secure. So what happens if they have bugs that can be exploited and so on?
But I was going to come on and say that in fact this is more of an issue when you consider, say, a celebrity as opposed to a normal person. Their phone is more likely to be stolen maybe than their cloud service being hijacked. So I think the principles are good, but they may be more steps to refine in these situations.
Absolutely, and I would think that it depends on the application and the type of data you're dealing with. Absolutely,
So sorry, I just wanted to not let you get away too much with. We need somebody in the middle who knows all about the state of the art in privacy. Because I've gone off and I've said this to other people, and then asked them for funding straight afterwards. But have you thought to any great extent about how you can resolve this problem for the industry as opposed to for the individual project? Because the slight criticism I had of this paper was that to some extent here are two case studies of how we solved very interesting privacy problems with some very interesting technology, and I love both the examples, but there are a great deal of more down-to-earth ways of providing a level of data minimization. I mean, you can talk as simple as something as hashing a biometric rather than storing the biometric itself. So have you thought at all about, or would you propose some kind of mechanism whereby you could improve the education at that level, sort of design patterns or something like that?
Well, I think we need to build primitives that are ready to, libraries that are ready to use by developers that don't need to be experts in crypto to use the protocols. My impression is that there is work being done in that direction, but of course much more needs to be done still.
I suppose to some extent it's a culture issue, because I think the other point, because
But you cannot expect the average
Yeah.
developer to have to understand
No, but
all
I
this
mean,
stuff to
some
be able to
extent-
develop a
to some
system. This is
extent,
not going to work.
We now have the culture where we do expect developers on projects to write relatively secure software, and we wouldn't propose a system where we would say you need to understand the latest iteration on gently homomorphic crypto system to work on the project as a security guy. So I mean, to some extent, I think I just want to say that data minimization is a very important principle, and I think it's actually, in my mind, it's actually probably more important than what's more broadly called privacy by design. I mean, it's part of the privacy by design principles, but I think it's so important that the others are more like satellite principles around it. But I think that this sort of education of engineers to give them, even when you're talking about functional requirements, I mean, you talk about having precise functional requirements, but I think to some extent it can also be down to how you state a functional requirement. You can, even if you state it very precisely, you can still state it in the wrong way for privacy or the right way for privacy. So I think what I'm just trying to tease out here is that there are slightly wider issues that still fit in engineering that aren't
absolutely
that maybe this didn't cover quite so well.
Yeah, absolutely, I agree. Yeah.
I think to pick up on the point, one of the biggest problems that I thought about privacy by design is actually there are very few incentives to build privacy by design into systems. An excellent example, a few months ago I had a flat tyre on my car. Luckily I saw a Tyres R Us place around the corner, great, I'd drive in there, get a new tyre. In order to pay for a tyre by cash, I had to give my name, my address, my telephone number and my email address, because the system, the order system, would not issue a tyre without me giving my telephone number and email address. Now, in terms of data minimization, this is absolutely terrible. This is absolutely appalling privacy. But you can see the incentives are coming from the marketing side of the business, saying, well, look, if we've got his telephone number, he's now a legitimate customer of ours, we can phone him. If we have his email address, we can send him specially selected offers on new tyres, whatever. And this organisation was clearly doing this. They had absolutely no incentive to minimise their data collection.
I fully agree, yeah.
People will come to you and say, great, we need to build privacy into these complex systems. It's wonderful, but this is happening very, very little.
Absolutely, absolutely. And this is why I think that it is crucial to somehow get the policy people to put more pressure, because it's not that the market is, automatically or by itself going to go in the direction that we would like it to go.
And even if an engineer says we need to reduce data minimization here, the marketing director is going to say, no, we need all this.
Yeah, absolutely. Absolutely.
No, I mean, the EU are pushing for, they call it privacy by default in EU research projects. This is now becoming a requirement for development of these systems. But particularly for that, your example with a tyre, my approach would have been to give them the information, pay in cash, and then immediately submit my request to delete all my personal information from the databases, which they're required to do under the Data Protection Act. So,
unfortunately, they didn't require me to give them a working email address nor a working telephone number.
In the end, you need the information commissioners to act on these cases, because I guess they don't. I mean, you must be able to access this service with that, or do what you say, like, okay, I give it to you, but then.
I mean, this is the case with a lot of design decisions. Is that this is the same with, say, environmental requirements. You can say this is how to design a system that doesn't need to use fossil fuels or something like that, but it had to be pushed in the regulatory end before it became. This is the case for a lot of engineering decisions.
Yeah.
Just to kind of revisit what those people have been saying, I think what strikes me is in this whole privacy by design is that it's a value. Well, no, it doesn't seem to cope with cost-benefit decision making. The concept it's either privacy or it's not. Whereas actually people trade privacy in exchange for things. And say you need to minimize data. Well, yes, but unless people are willing to share their data. And so that's what I liked about the underlying principles, actually, their risk analysis, security engineering methodologies, which are all about cost-benefit decisions. You know, is this worth the risk, yes or no? Do I need to put more money on my defenses? And I think the same is true of privacy. Do I have, because to take the tire example, take a bigger picture view, they're very likely subsidizing the cost of the tires through their advertising and marketing strategies. So you're ending up paying less for the tires than you would than if they didn't have this particular marketing strategy. So it all ties back to there's a benefit to you for sharing this information. Now, having that particular benefit explicated and put in explicitly in the design of the system is an extremely good thing. And I think we need more tools, and a lot of these things can help. Appealing to the concept of we need privacy in a kind of blanket term is less meaningful because we're not that black and white.
Yeah.
And that ought to be reflected in the tools.
Yeah. No, I agree. I mean, to me, the main problem is to hear privacy by design. The term is a buzzword everywhere, and then see that most people who are using it, it is completely empty. So, you know, maybe in some systems we don't want to have privacy, or maybe society wants to give up on privacy. That's fine, but at least let's not pretend, right? I mean, let's be honest about it. So to me, the problem is, I mean, if for whatever reason a system, a company says we want to grab as much as we can, and this is what we want to do, and if you don't like it, it's your problem. I mean, fine. But no, the problem is that they are doing that and telling you, but this is privacy by design, so don't worry. So it is a bit too much in that respect. On the other hand, I also wanted to mention, yes, of course, the fact that you design, okay, so doing privacy, sharing information is always easy. Doing things without revealing it is difficult. So in a way, to have a system that by default doesn't reveal information does not prevent you from then revealing the information itself. So if you think of the road tolling, for example, nothing prevents you from taking your own data from the car and publishing it on the internet and sharing it with everybody, or sharing it with the company in exchange for a discount, selling it. Or the same with the petitions. You could do the same. So it's not that because a system is designed in a way that it minimizes data, that it's impossible to actually disseminate, share the data or make it public. It's just that it's not going to happen in the infrastructure by default.
It would be nice to have a choice.
Yes. But
right now you give away the data for free, so why would anyone design something like that of their own initiative, right? Like you said,
it has to be mandated,
it's
yeah?
much easier to share,
Yeah, sure.
so.
Yeah.
So if you think about these service providers, again, because in the other project we have troubles getting service provider ready to help us, because as soon as we approach them, they think that we are gonna change all the possibilities they already had. So they feel like constrained, or they have to invest a lot of time and money in something that they don't see a direct outcome. And also the big problem is also that service providers themselves, they don't know their risk. For example, if you look at Safe Harbor, a lot of people who, and also universities, who use SurveyMonkey and other stuff, they're not really aware of what they actually are doing while they themselves are going into the field using it. So there are a lot of links when you have this relationship with a service provider, still you have to know more what's going on in the back. And the difficulty is that you want to actually explain it to normal people. Lots of people, like people 50 plus, they thought privacy was something that was in the home, and actually now it's on the streets, and they don't really understand that, so they get very frightened about all these things happening. And it's also trying to communicate those difficult aspects, more engineering aspects, in a way so that people feel comfortable in using those systems. So that's probably why there is a lot of criticism, and we also have to deal with that and trying to become positive and try to help people.
Yeah.
Okay, and I don't know what kind of research you want to go with privacy by design. If it becomes really technical, or do you want to make it socio-technical, that you also take the social side of the...
I'm mostly interested in the technical aspects. But like one of so Seda Gurses, so is one of my colleagues. She's actually more in between the technical aspects and the more socio-technical aspects. So the team is a little bit diverse in that respect.
So are you also confronted with those social aspects when you are trying to bring technology, that you are confronting people who are worried about the social part? And do you know how to deal with that as well? Or do you try to, minimize that interaction?
Well, I think you have to draw the boundary on what is the job of the engineer and what is out of the job of the engineer, right?
Cannot an engineer be a little bit a sociologist, and a sociologist a little bit an engineer, so that we understand the...
I think it's important to have good communication, but I don't know. Yeah, that's a difficult question. I don't know to what extent you should sort of enmesh everything, or whether you should have a more clear separation of duties in which some people are in charge of defining, like, is this legitimate and is this ethical or not, and if yes, what is what we want to achieve, and then you want to give this specification to an engineer that is actually going to make it happen in technology. But I agree that it's more complicated than that. You have all kinds of interactions of users with the system and so on.
Because you talk about these checklists, you want to prevent those checklists.
Yes.
Engineers love checklists.
Of course, yeah.
So I love checklists as well. So then I can say, look, I did it. I feel happy. I did all
Yes.
these things. So and the empty one probably a little bit more. I don't know.
Yes. No, it's I agree. It's complicated. Yeah, absolutely. And it's not just technical. Yeah.
Okay.
Okay. Thank you very much.